Today we're going to talk about another kind of measures of relative standing. And we also need to introduce another statistical graph called the box plot. So first, we will talk about what is the relative standing. So relative standing means the numbers showing the location of the data value relative to other values in the same dataset. The location of each data values relative to other data values, we call it relative standing. So compared to other values, what's the location? So that's the basic meaning of relative standing. Of course, it should be in the same data set. Okay, so in this section, the most important part is the z-score. So we start to talk the z-score. You will see this z-score for a long time, almost in the whole semester. Okay. And we also need to talk about a little bit about percentile, quartiles. And we also need to learn how to draw a box plot. So first of all, z-score. Z-score is just the number of standard deviations. How many standard deviations is this x value above or below the mean? So z-score is just a standardized score to tell us how this x value is above or below the mean value. And how can we get the z-score? We use this formula. So this x means each data value, and minus mean value divided by the standard deviation, which means how many standard deviation away from the mean. So that's the definition of z. And we have two formulas. One is for sample, another is for population, but most of the time, we will just use this sample formula because most of the time, almost all the time, we work on the samples, not the population, right? But they are just the same meaning. Individual value minus mean value divided by standard deviation. Just measure value x is how many standard deviation away from the mean. And the round-off rule for z-score, just keep two decimal places. Because when you check the z table, you will realize there are two decimal places in your z table. Okay, check the properties. Properties just helps us to understand what is z-score. Although it will not be tested in your exam or in your quiz, but I still need to learn something about the properties because it helps us to understand. The z-score, by definition, just tells us how many standard deviation away from the mean. So the second one is z is a standardized score, so no unit. Not like any other measures, mean, median, mode, variance, standard deviation. They all have units, but z do not have units. And the third one we talk about significantly low. If the z-score is less than or equal to -2, which means, by the definition, which means the x value is 2 standard deviation below the mean, or even lower. So this kind of value, we call it significantly low. Or the value is significantly only if its z-score is greater than or equal to +2. We will check the example later to help you understand this property well. Okay. So next one, if this x value, if the data value is smaller than the mean value, so if we have the x value 3, but the sample mean for the whole data set is 5, then this x value is smaller than the mean. So the corresponding z-score for the x value is a negative number. Okay. Let's check the example to help you understand. So, which of the following two data values is more extreme relative to the data set from which it came? So that means we have two data values from different data sets, but we still can compare which one is more extreme. So first is the data set of the baby weights, the newborn baby weights. And the second one is human body temperature, right? So we will need to compare two values. So the first one, we will have the x value, 4,000. And the second data, we have 99. We have these two different values, but we want to test which one is more extreme. Let's check how to do this kind of questions. Because they are from different data set, we cannot directly compare 4,000 to 99, right? So which means we cannot use the original values to do the comparison. So we need to standardize the values to a z-score, because z-score is a standard score. Then we can compare the standard score. So first, we should get the z-score for both x value. So for the first value, 4,000, how can we get the z-score? We use this formula because it's a sample value, right? We pick x value. So x is the score, is the value we want to test. So this is the x value, 4,000. We should minus the mean value. And for the mean value in this sample, we know it's just 3152 divided by the standard deviation from that data set. We will get it's 1.22, right? So we do the same thing for the second x value in another data set. So I still use the same formula, z. But this time, the x value is 99. And the mean value is from the second data set. Standard deviation is also from the second data set. We get another z-score. Now we can compare these two standardized scores. We can compare which one is more extreme. So by the definition, 1.22 for the first value means that value is 1.22 standard deviation above the mean because it's a positive value, right? So it means 1.22 above the mean. For the second value, 99 degree, it's 1.29 above the mean, also above the mean because it's positive. So we only need to focus on the numbers, 1.2 to 1.29. Of course, 1.29 corresponding to 99 degree. So 99 degree body temperature is more extreme than a birth weight of 4,000 grams. Again, we cannot directly compare the x values 4,000 to 99, right? Because they are not from the same data set. So we should standardize these x scores to get z scores. Then we compare z scores to see which one is more extreme. Then we can get to the conclusion. So this is the last sentence here is the interpreter of the question. All right, we can use z-score to identify significant values. So in this graph, we can easily find if any value on the left tail, which means any value with z-score less than -2 or even smaller than -2, for example, -2.5, -2.8, -3. This kind of values, we call them significantly low values. Similarly, any values with z-scores greater than or equal to +2, we call them significantly high values. Of course, we have another situation. 95% of the data in the middle are not significantly at all. They are not significantly. So we have 3 options. Make sure you understand we have 3 options. Most of the data, 95% of the data, right in the middle, we will say they are not significant. But if the data values 2 standard deviation below the mean, which means the z-score is less than or equal to -2. So this kind of score, we call it significantly low. Of course, similarly, 2 standard deviation above the mean or z-score is greater than or equal to +2, we will say this kind of value is significantly high. So 3 options: significantly low, significantly high, and not significant. Let's check this example. So let's have this data value. 75. The lowest count in a data set is 75. Is that value significantly low? If we already know the mean value is 239.4, and of course we need another important measure, standard deviation. So if a question is about significantly low, we should know maybe we should use z-score to get to the answer. So the first step is try to translate the x value to the standard score, z-score. So the 75 is the x value we want to test, right? Is this value significantly low or significantly high? So make sure you put the x value, the value you want to test for the first term. Then minus mean value. Here mean value is 239.4. So I should say here lots of students will make a common mistake. They always put the large number minus the smaller number. That's totally wrong. Always make sure put the x value, the value you want to test for the first term. Okay, it's possible to get a small number, even smaller than the mean. So it's possible to get a negative value. Do not always use the greater one minus the smaller one. So here, in this case, 75 is the value we want to test. So the first term will be 75 minus mean value divided by standard deviation. We will get this z-score. So it's possible to get a z-score, to get a negative z-score. If the value is smaller than mean, then your z-score is a negative number. Now we will have the z-score. We use this z-score to answer the question. Is a count of 75 significantly low? Remember the rule? We'll go back to check the graph. So go back to here. When we can say it's significantly low, if the z-score is equal to -2 or even smaller than -2, we can say it's significantly low. So for this question, we get the z-score -2.56. So we know -2.56 is smaller than -2. Then we will say, yes, 75 is significantly low. Okay?